Hey, very good morning, students. Let us see the next topic called D-Latch. So, latch is a circuit or a memory element which is used to store single bit information. So, latch can store either 0 or 1. So, this is a D-type latch. Let us see what is D-Latch. Okay, D-Latch is a logic circuit which is most frequently used for storing data. Okay, most of the digital systems use only D type of latch for storing the data. Data can be stored in D latch. So this D latch is based on what? SR latch. Okay, this D latch is built with help of SR latch. In SR latch, we have seen SR latch in the previous video. This is a construction of SR latch which has two inputs, S input and R input. We have seen the truth table of SR latch in which the input, if it is 0, 0, the output is memory. It acts like a memory. If it is 0, 1, the output is same 0, 1. Input is 1, 0, the output is same 1, 0. If it is 1, 1, it is an invalid state in SR latch. Whereas D latch overcomes the drawback of SR latch. In SR latch, we have a state called invalid. In D latch, we will be avoiding that state problem. So it is based on SR latch, but it doesn't have that invalid or undefined state problem. Okay, so let us see how to design a D-latch using SR latch. Okay, so this is the block diagram of D-latch. Data input is given to D and you have a single input D and there is an output Q. Apart from input D and output Q, Q is the output, Q bar is a complement of the output. In D flip-flop, we have a special signal called E or enable signal. So D is a single input and there is a control signal called enable. E is known as enable control signal and you have two outputs, Q and Q bar. Q is data out, Q bar is a complement of data out. So why we call it as D flip-flop? D stands for data. So I can call it as why we call it as D latch? D is called as data. So I call it as data latch, or in short I call it as D latch, which has how many inputs? Two inputs. What are they? Data in and enable. It has how many outputs? Two outputs. One is Q, another one is Q bar. Let us see the construction. We know D is a flip-flop which is derived from SR latch. D is a latch which is derived from SR latch. I have taken a SR latch. Can you see the SR latch is taken here as such. After taking SR latch, what I am going to do is, I know D has only one input. Okay, so this is my D input. This input is first complemented. I am using a NOT gate and complementing it. So I get D bar here. Okay. This is fed to one of the input of AND gate. And there is one more input called enable input. So this enable input is given as one of the inputs to this AND gate. So D flip-flop is connected to SR flip-flop by truncating the two inputs to a single input. So D as a true form will go to yes, as a complement form will go to R, along with what? Enable. So this is the construction of D flip-flop from SR flip-flop. So D flip-flop has two inputs, D and E. So this is my D. One is true going to S, other one is complement going to R. Other input is enable input. Directly I am giving that enable input to both the gates. Here we need to be careful. We have to use AND gate for the construction. This is the circuit diagram or for construction for SR latch. Okay, S and R latch using NOR gates. So this is the circuit diagram for D latch. Okay, now let us see how this D latch works. So this is the truth table. So whenever, see this case, in this first case what I am saying is, if enable is 0, if enable en is 0, what happens to my output is what I am going to see. So this is my case 1. If enable is 0, I am making enable as 0 and D as a don't care. What is don't care? Don't care means X. can be either 1 or 0. D can be either 1 or 0. If by chance enable is 0, what happens? One of the input, the enable will come to AND gate. Same enable input will come to this AND gate. We know the truth table of AND gate. AND gate input is 0, output is 0. So in AND gate, anything multiplied with 0 is 0. Anything multiplied with 0 is 0. So what is the input that is coming to R and that is coming to S? When S and R both are zeros, it acts like what? Memory. So output is acting like what? Memory. So whenever enable is 0, irrespective to the D can be either 0 or 1. It can be a don't care. My S will be 0 and R will be 0. When S and R are 0, my output will be what? S and R are 0, output will be what? Memory. So output will be memory. So to derive a D flip-flop, we need to know the truth table of SR latch. Okay, so this is the first case. Now I am filling the truth table. When my enable is 0, my input D is X. It can be either 0 or 1. My output Q is memory. So I am done with first case. Let us see the second case. So what is my second case? When my enable is 1, I made my enable as what? 1. So make this enable as 1. And my D is 0. Make this D as 0. 0 is passing through the inverter gate. Output of this is 1. So I fed 1. My enable is 1. You know my enable is 1. So the enable is passed through this gate 1 and it is coming through this wire 1. You know D is 0. So one input is 1. Other input of D is 0. 1 into 1 is 1. 1 into 0 is 0. Clear? So when R is 1, S is 0. See the truth table, R is 1, S is 0. What is my Q? 0. My Q becomes 0. Q bar becomes 1. Q bar becomes 1. Fill the truth table. When enable is 1, D is 0. What happens? 0 comes here. 0 complement is 1. 1 moves to this AND gate. 0 comes directly here. Since other input enable is 1, 1 into 1 is 1. 1 into 0 is 0. So R is 1, S is 0. R is 1, S is 0. In this case, Q is 0 and Q bar is 1. Q is 0 and Q bar is 1. So when input D is 0, my output Q is 0. When input D is 0, output Q remains 0. This is my second case. Now let us see the third case. See the third case. What is my third case? Enable is 1, D is 1. Enable is 1, D is 1. Pass the D to the two inputs of AND gate. One directly coming, other one is going through a inverter gate. So one passing through a inverter gate, output will be 0. And you know enable is 1. When enable is 1, enable input is coming through this wire. So what is the input to this AND gate? 1 into 0 is 0. 1 into 1 is 1. Now I know R is 0, S is 1. So R is 0, S is 1. When S is 1 and R is 0, what is the output Q bar? 1, 0. Output Q is 1, Q bar is 0. Output Q is 1, Q bar is 0. Fill it. When D is 1, Q is 1. When D is 1, when D is 1, S is 1, R is 0, Q is 1, Q bar is 0. It means when I give D as 1 as an input, my output Q will be same, 1. So when I give D 1 as an input, output will be same, 1. From this we could understand the truth table of D flip-flop. What is a D-Latch? What is D-Latch? D-Latch is also known as transparent latch. What is transparent? Can you see? This is the block diagram of D-Latch, which has one input. Other input is enable. It has one input. Other input is enable. When enable is 1, whatever you give as an input will come as an output. When enable is 1, output is equal to input. Can you see? When enable is 1, my output is equal to my input. When enable is 0, output is equal to memory. Output is equal to memory, whatever be the value of D. When enable is 0, output acts like memory. When enable is 1, output will have the same value of input. That is why you call it as transparent latch. Whatever is there in the input will come as output when enable is 1. Or I can call it as data latch or gated latch. So this is the functioning or working of D-Latch. Thank you.